All right. So today we'll be presenting the Unit 2 presentation on the mapping demonstration. Today I provided a PowerPoint slide based on the instructions that were given in the assignment. So we'll start off by going to step 1, which is where we determine the grouping and crossover categories based on the data set that was given to us. So as you can see to the far left here, we have the data set that was given. And the second row, we have those particular data sets grouped together. And then to the far right, we have our total amount of offspring given for this data set. So in order to find the specific groups that are provided, to find the non-crossover group, we want to take the two highest amount of offspring groups and add them together. So that gives us 2702 and the NCO, which is a non-crossover group. The second one down, and then to find the double crossover group, we take the two lowest offspring that were given in the example, which is the 100 plus the 140. It gives us a total of 240 for the double crossover or the double recombinant class. And then the other ones are the ones that are as close, are also grouped by in close number as well, and they are our single crossover groups or our other recombinant classes. So we got a total for one of them as 1980, the 970 plus the 1010, and as well as the second one, which is 400 plus 420, which gives us an 820 single crossover group. And the total for all these groups is 5,742 again. So then we go to the next step, which is determining the gene arrangement. And in this typically we would normally look at the double crossover group, and that would depict how the genes would be arranged with a given data set. And for example, in other cases it could be an ACB, a BCA, it could be plus C plus, it could be plus AB. So many different examples that could be for those three letters, and also for the different plus signs that would correlate with those different data sets. But for this example, every example listed was in the same order of ABC, so we did not have to really depict it for this specific given example. Moving on to step 3, we determine the distance between the genes. For this one, we're going to take the total for all of the different groups and divide them by the total amount of offspring that we got. So for the NCO, or the non-crossover group, we took our 2,702, divided it by 5,742, and we got 47%. For the first single crossover group, we got 34.5%. The second single crossover group, we got 14.3%, and for our double crossover group, we got 4.2%. And the main numbers we're looking at in this particular example to move on are the last three percentages. Pretty much everything other than the non-crossover group. So in order to find the distance between A and B, we are going to add that 34.5% by our double crossover group, and we're going to get 38.7. Again, to find the distance between B to C, we are going to take that 14.3% and add it by 4.2 to get 18.5. Using that 4.2, again, we're going to use that to find our observed double crossover percentage of 4.2 divided by 100 to give us a 0.042, which again gives us our observed DCO percentage. Moving on to step 4, where we found we were able to calculate the coefficient of coincidence. A to B was that 38.7 percentage that distance we found from A to B. We divide that by 100 to get a 0.387. For B to C, it was 18.5 divided by 100 to get 0.185. And then we use those two numbers to find and multiply them to find our double crossover expected value. So we multiply those two numbers and we get 0.072. We multiply that by 100 to turn it into a percentage, and we get 7.2%. From this, we take the 0.042 that was found in our observed DCO from step 3, and we divide that by 0.072, which we have as our expected DCO, and we get a 0.583 as our coefficient of coincidence, which we then, moving on to step 5, we will use again when we calculate the interference. And the interference is found by subtracting that 0.583 by 1 to get 0.417, which when turned into a percentage by multiplying by 100, we get 41.7%. Based on this value, we can conclude that this interference is a positive interference because of the positive value that was provided which also means that there is about 41.7% more double crossovers expected than actually occurred. And that concludes this answer to this problem. Thank you.